Hi everybody. My talk is about a closer look at Pandas indexing. Who's working with Pandas? Please all raise your hands. Very well. Who has really worked a lot with Pandas and really looked into indexing at all? Okay. So fine. So very good. I'm Alexander. I'm from Mannheim in Germany. Mannheim is a 3 hours train ride from Paris with the TGV. I'm working with a strategic data consultancy for startups and middle-sized industries. I'm also EuroPython and German PyCon program chair and organizer this year. So what we're going to cover today, we're going to take a closer look at the indexes. So just like a little quick catch-up for everybody on how to access Pandas indexes, how we can use it, index types, then we're going to look into the multi-index and a closer look at the daytime index, which is actually my favorite one. So, real quick catch up. So in Pandas we have a series, and it's a NumPy series, and a NumPy list with label is what we call in Pandas a series. So that's basically it. That's the data, that's the label. It's very simple. Oops, sorry. So how can we access a single series? We can access it by just like passing in a position. We can slice it, and of course we can also use the ilog method and pass in a slice, and it will always return a slice for us. We can also access it by a label, like a text label. So I just like re-indexed our series with like letters, and so now this is these are the labels, this is the data, and we can access it still via the position, which is actually Pandas is guessing this because when we put integers in, or we can also just pass in the letters. So we can give us back everything from D to F. So it's very simple. I think I can wake you up in the morning and you will do this. So, can we slice multiple series? No. But if we want to do like have two columns or two values from D to F or I to J, we cannot do this directly, but we can use the concat method and just like pull in and concat two series. So, next. Let's index our series with something a little bit different. Before we had a unique index, it was the letters A to Z, and now we use Gattaca X, Y, Z as an index. So these are our labels, these are values, so which implications does this have on accessing our data? So we still can use the log method or directly use square brackets and put the letter G to get our first value. We can no longer slice, even using the log methods from G to A, because we get a key error because G or A is no longer unique. We have an A here, we have an A here. Still, the whole thing is not broken yet. We still can slice in the unique part, for example, from X to Z, which is just like unique values. Okay, might be confusing for a beginner. So, okay, this was just like an overview on the index. The label of a series is usually called the index. It's automatically created, if not explicitly given. You can also pass in your labels when you import data. It can be reset, it can be replaced, as you just saw. It's very simple to replace it. It can only contain hashable objects. So of course you can not just use like string labels. You can also use, for example, a tuple, which is a hashable object in Python. And it may contain a value more than once. The index values are of course unique, but the index itself might not be unique. So that's a little caveat to watch out for. We have multiple index types, just like the simple one we just saw. We have the multi-index, we have a daytime index. I'm going to show a little bit more about the multi-index in a minute, and then of the daytime index as well. So the daytime index is an index of datetime objects. We can also use time deltas intervals and categorical indexes, which is pretty neat. But we're only going to go a little deeper look here. The general Pandas structure is, so we have our data as a NumPy array with a label we call the index. It's a one-dimensional series. And, oops, that was one slide. Let's go back. So this is our series. And if we have multiple series basically glued together by the same index, because this is like all the same index values here, we have a data frame which is two-dimensional and very often or mostly still referred as a table, as you know from other formats like Excel, CSV tables, and it's also like rows and columns we often refer to in Pandas. So there's another data structure called panel. It's three-dimensional, but it's just been deprecated. So probably forget about it. But instead of panels, we can utilize the multi-index, which I'm going to show you in a minute. So one more. So let's jump to data frames. The data frame is just like two-dimensional data. So this is just like some random data frame with some random values in 10 series. And how can we access the data here? It's just like the same, where we can pass in 2, but it now gives us the column. Because in the series, we got the value at position 2. If we have a data frame and pass in just like a position, it gives us back the column. And since it's not confusing enough, if we put in a slice, we don't get columns 2 and 3 back, we get the rows back. So this is sometimes beginners really struggle with in Pandas because it's a little bit, might seem illogical, probably. We also can still use the ilog method to get a segment, for example, from the data. So we can pass in here, this is axis 1 and axis 0. Sorry, it's axis 0 and axis 1. So this is still the rows, but we can also access column values. So it's very easy to slice out just like a subset of your data frame if you want to look deeper into it. And of course, this will also return a new data frame, including the index values we have here. So, and if you want to get a whole column, you can just pass in a column to give us all the rows and slice the columns. So, and if you can't remember about the axis, so as I said, like the rows is axis 0, and the columns is axis 1. Yes, I have trouble remembering. So that's why I came up with this. Or no, actually, I saw it online. Actually, like to remember axis 1 is the column, and you can remember a little bit like, we call it like, it looks like a 1. So that's, yeah, that's, yeah. So, okay. Now we know how to slice and access the data. Let's rename our data frame. So we just, here we just, I'm just like resetting, we're setting new index, we are resetting our index and call it like rows, like numbered, and columns here to make it a little bit more clear. And accessing is still the same. As we know from before with the series, we can just access the data with the label. Slicing, or slicing row values, and we can also get segment just like the same, just instead use values, the values of the labels, and no longer positional integers. So now the first handy thing with the index. What if you have a data frame and you have probable multiple CSV files, or you have additional data? So how can we actually add the data to our data frame? And here the index is really very useful. This is a new additional data frame, or a series furthermore. It's also just like the same, it's just like random integers, and they, but as you see, we start not at R00, the first label is R03, and it has the same length, but so it ends at 12 and not at 09 as here. So we can just like add a new column to our data frame as we would add it to in a dictionary in Python. So we can just say, okay, the column name, we just call it C10, and we pass in the data frame. And this is what we get back. So if there's no match here on the index, Pandas will just put a null one, an value there, and basically skip everything which is unknown to the data frame. So these are gone. All the rest is added, and where we cannot figure out what it is, it's just NaN. But are there any smarter ways? Can we join data better? We can also use the join method. So we this just like makes a data frame out of our data series, and if we do an inner join, we just get a data frame back where we have basically have a match on both indexes. So we lose the first 3 rows of our original data frame and also the last 3 rows of our new data frame. And of course, usually if you want to get data in, you don't want to lose any data. So probably like the outer join is more useful. So with the outer join, basically, Pandas will pass in the new data series here, add new columns to the data frame you had at hand before. And if you don't like NaN, you can put like standard values in there with the, you can replace NaN values with default values, nothing, whatever you wish. There's so many ways in Pandas. There's also, if you have an SQL background, or if you have worked with SQL language before, it's the same logic. We have left, we have an outer join, we join everything together. We have the left join, so basically on the left side is the one, our start data frame, and we pass in the new data frame, so it's the same as if we pass in the data directly. But we can also do a right join, and basically the right join, the right table is the new one. So this is like prioritized, and then we get it this back, and the rest is filled with NaN. So a multi-index. The multi-index, let's see, we have a new data set here. It's just like cities, prices, ratings, country, and a category. And the multi-index, you can create data frames explicitly when you import data, but I usually come across it when I group by. So what if we want to group by country, city, and the category? So we can use this. This gives us back a group by object, and if we put a method in there, so let's get the mean for all the other series, we could return this. So this is a hierarchical index data frame, country, city, category, and then we have the mean values for price and some rating. And that's basically, if we have a little, if you look a little bit deeper, what we have, if we ask for what's the index, it says it has a multi-index and it has just like certain levels. So it's a very easy, very simple hierarchical index we can use and just like walk through. And internally, this is everything stored as tuples, as you see here. And of course, following the same logic, we can also get certain levels if we want to. Like this is like that's the third level. So this is also zero indexed, and this gives us back the values, and we can also go one level up and see, okay, that's the cities, and still our series still has a name. And of course, we can just also just like access objects as we're used to with the log method and get like everything from Germany here, or walk down basically the path and say, okay, give us France and Paris, and we just get the categories here. And I think it's a really nice feature. We can also walk down the path and get the max value. And if you see, the max value is not just like one row where we have one max, or it's the ultimate max of both rows, if that was even figurable out, if you even could figure that out. So basically, if we call the max, we will get the price here, which is here in 3. and the rating is here. So this is really nice if you want to see what are the max, so we still can see what are the max values in our individual series. And of course we can also go even one level deeper. And now my favorite index, the datetime index, because sometimes or often data has some timestamps if it's seconds or just like months or whatever. So we have a very easy open data set from Aarhus in Denmark, which is just like timestamps and the float, and that's the temperature in Celsius. So once we imported the data, and we also already set like column names, we have a timestamp, which is still a string here, and a temperature. We could also like, yeah, and then that's like the plot of the data as read in. So let's create our data time index, and this is quite simple. There's a method, it's called toDateTime, and we can pass in the timestamp string here, and it will return a datetime object. Yeah, like and Pandas is very good in guessing data formats, but it's of course, if in doubt, US friendly on this method. So probably if you want to be sure, you can pass in just like the format as you can use in the Python string format. So and make it more explicit so your data is passed right. And once we have a datetime index, if we plot the data, it's already sorted. And if you remember, this was just like, because it's multiple sensors. So once we have an index, all plots are already sorted. So Pandas and Matplotlib figure all this out and give us these nice sorted values back. But there's more. This is just like, let's have a look at the index. So you see it's a datetime index now. With all the timestamps, and internally it's a datetime 64. It has a name, and it can also have frequencies, but we don't cover it here. Let's do a simple group by, and just like see how many measurements we have for each and every day. So, and now it gets really nice. So what do we here? We group by the index date. And we just ask the index and give us back the dates. Don't give us back each and every timestamp, just give us back the dates from the index and group by the values we get back here and just do a count. So we see these are like the counts we have for each and every day. And we have the same for the week. So it's really easy to get the week from the index, take the mean and plot it out. And you have basically everything in there, like dates, hours, seconds, and something like that. If you ever wondered if the weather or like the temperature on weekends is higher, this is something like, at least in our data set, you can easily create a new series and ask for the weekday. Funny, the weekday, Monday is 0 and not Sunday as in the US. So this is the European standard here. And then we just ask, is it a weekday? Is the weekday in the weekend? So we ask for 5 and 6. And then we can just like plot these two values, and we see in our data set actually the temperature on weekends is a little bit higher, and it also gets warmer a little bit earlier. So we can also just like look at few things like just like a specific date. We can just pass in like a date string and get the temperature back or like the values back for this date. So just pass in a string. Here we use a year, month, oh sorry, it's the month, the year and the month as a string. And we even can slice by days. So we can pass in like 2 days, and these are the temperatures for these 2 days. And the same, we can also ask for the hour and just get like data back from which are measurements between 12 and 4 o'clock in the evening. And like that. So this is really handy. So you don't need to worry about to get any functions and other stuff done to work with the datetime data. So on the last nice feature, once you have this, that we can also resample the data. So you can just resample and pass in D, and this is like resampling for the day, and get the maximum, and yeah, look at it. You can resample by month. You can also resample by day and chain an aggregation and get the minimum and the maximum value, for example. And you can also build stuff like this, like 3 days. So you can resample by 3 days if you want, if you have any use for that. This is the full Pandas resampling power. These are all the methods. These one I knew. Very of them are very from the financial world. So I think, as usually in Pandas, everything's built in. And yep, that's the end of my talk. Just like 2 community announcements. EuroPython is coming up. It's in a few weeks, and it's in Rimini, Italy. We have some awesome keynote speakers, a PyData, many trainings and stuff. And also, just like 3 hours by train away, direct connection to Paris is the German PyCon. It will be in English only. It's in Karlsruhe, which is one of the technical hubs in southern Germany, and the CFP is open, and we also have a PyData track there. So thank you very much. If you have any questions, feel free to ping me on Twitter or here. I'll be around until tomorrow. Thank you.